Hello everyone, today we're going to be talking about Chapter 11, Authentication and Account Management. So objectives for today, we're going to describe the different types of authentication credentials, explain what single sign-on can do, and list the account management procedures for securing passwords. So there's different types of authentication credentials, and they start from where you are, what you have, what you are, what you know, and what you do. So where you are is specific location. What you have, is it a key fob or is it some type of key? Physical device, right? What you are, you yourself as a human. What human element? What are you? What you are? Do you have specific eyes, fingerprints? What you know, something you know, password maybe. Combination, and then what you do, how fast you type, or how many minutes, how many keystrokes per second, or how fast you click. Right, do something to prove authenticity, right? Push-ups, what he does, yeah. So what you know, so passwords. User logging into a system asks to identify himself, usually enter in your username, and then user asks to authenticate, and then you enter in your password. Passwords are the most common types of authentication methods today, and they're actually only a weak type of, they're actually pretty weak. Actions can be taken to strengthen passwords. Weaknesses of passwords usually is linked to the human memory. I don't know the biology behind it. Humans can memorize only a limited number of items. I don't know about that, but it's essentially long and complex passwords are, even though they're the most secure and most effective, they're the most difficult to memorize. And users must remember passwords for so many different accounts these days. I personally have like 20 emails, right? Technically, each account password should be unique, but there's so many people out there, they can't remember, so they use the same password over and over and over for every single one. If one of those passwords gets breached, now, for example, they have access to every single one of their applications and accounts for everything, from their Facebook to their bank account, all one password. Now they have access to it all, right? Security policies must be mandated for passwords. Mandate passwords must expire and be a specific amount of length. So users must repeatedly memorize passwords. So moving forward, actually, I don't agree with this. Security policies not always has to require passwords to be expired. I think the frequency needs to drop a little. Having passwords expiring every 30 days is not the most optimal, because then people can't memorize it and they start writing their passwords down on their desk. After an account has been breached, definitely reset those passwords, but if you ensure a long password, a passphrase with less complexity, it's more important than, for example, 8-character, different types of characters, symbols, whatever, password. So user often takes shortcuts using a weak password, common words, short passwords, or personal information. Don't use your social security number as your PIN. When attempting to create stronger passwords, they generally follow predictable patterns using letter, numbers, and punctuation in a pattern, or appending and replacing. Appending is just adding or using letters, numbers, and punctuation in a pattern, or replacing. Users use replacements in predictable patterns using the @ sign instead of a, using an exclamation mark instead of the I, or a 1. So here is the top 10 passwords used out there, right? They're pretty predictable and easy. Just for reference, an 8-character password can be, doesn't matter what type of complexity it has, it can be cracked within 16 seconds. So increase the complexity of your passwords. The more you increase it, it takes longer exponentially. So attacks that can be used to discover passwords: social engineering, phishing, shoulder surfing, dumpster diving, looking under your keyboard, capturing. Passwords can be captured through keyloggers, in the middle attacks, keyloggers, put in a specific USB into your computer where you don't know that's been connected to, and it just like collects your keystrokes, or man in the middle, right? Something sent over the wire. You're trying to log into Facebook, and someone grabs that data, listens to it, and now has your password. And then resetting, attacker gains physical access to a computer and resets the password. Then you don't even have access to your account anymore, unless you reset it yourself again. So attacks on passwords. Usually when you're cracking a password, they're taken offline. Attackers usually steal the file of password digests. The digest is the output of a hash. And they compare those with their own digest that they have created. So for offline password attacks, they include brute force, mask, rule, dictionary, rainbow tables, and password collections. So brute force is essentially every possible combination of letters, numbers, characters used to create an encrypted password, and they just slow and methodical, most thorough method. It just goes through every single possible combination until it cracks that password. An NTLM, New Technology Land Manager hash. It's an attacker who steals the digest of an NTLM password, and he would simply, since that digest the digest is the output of the hash, it kind of represents the password. And so what the attacker does is, instead of actually knowing the password, it just uses the digest to authenticate, and it can authenticate to different resources and services, and that's called the pass-a-hash attack. A mask attack, it's essentially a targeted brute force, where you use different placeholders on different characters in certain positions. Parameters can vary from character set, language, patterns, password length. Sometimes instead you go through a brute force, but instead of the letter A, you always use the @ symbol instead. A rule attack, it conducts a statistical analysis on the stolen passwords that is used to create a mask to break the largest number of passwords. So a dictionary attack. So a dictionary attack is essentially an attacker will take a list of dictionary words and finds the digest of those dictionary words, and then they will take it and compare it against. They'll steal the digest file of a computer. For example, in a Unix box, there'll be an it'll be an Etsy shadow file, and he'll take those digests and just compare of the list of words that he gathered, probably in a database or some type of list, and got their digest, and then it just compares every single one of those to all the digests within that Etsy shadow file, for example. If one matches, awesome, they get in. Birthday attack, a search for two digests that are the same, any two digests that are the same. Right now, rainbow tables, pretty much, the attacker creates a large pre-generated data set of candidate digests. It essentially looks at the permutation of every single plain text password possibly created. So I'll go through those steps of the rainbow table. It gets a little complicated, but except for using a rainbow table, you first have to create the table, right? And once you have a plain text password, it kind of creates a chain. So chain of plain text password, and you encrypt it, and you encrypt that password, and then you feed it into the function that produces different plain text passwords, and repeat that for a set number of rounds to create a series of permutations. And then using the table to crack a password, you run encrypted password through the same procedure used to create the initial table, resulting in an initial chain password. Now, using the table to crack a password, repeat starting with the initial password until original encryption is found. Password used at last iteration is the cracked password. So rainbow table advantages over other attack methods are that it can be used repeatedly, faster than dictionary attacks, less memory on attacking machine is required. To dumb that down, pretty much it goes through every permutation of a plain text password being sent through a hash algorithm, because it looks at the chain of permutations. And once it found a specific chain, then it knows, what that word was, or password was. So password collections. Oh, probably should. Swap this. Attacks on passwords. Using the table to crack a password. Repeat. We already got through that. So password collections. In 2019, an attacker used a SQL injection attack, and more than 32 million user passwords and clear texts were stolen. These passwords provided two key elements to the passwords, gave attackers a large corpus of real-world passwords, have provided attackers advanced insight into the strategic thinking of how users create passwords. So essentially, the whole point of this slide is to say, 32 million passwords are stolen, and those are pretty much took those 32 million user passwords and use them in as a baseline of most commonly used passwords and potential passwords that they can run against. So securing passwords from attacks depends upon the user as well as the enterprise. For the user, it involves properly managing passwords. For the enterprise, it involves protecting password digests. Managing passwords, the most critical factor in a strong password is the length. It doesn't matter about the characters or special characters as much as the length. In addition to having long passwords, it's recommended do not use passwords that are in the dictionary or phonetic words. Do not repeat characters or sequences. Do not use information about yourself. Also use it's recommended to use non-keyboard characters. I didn't know this until about 5 years ago. If you hold down the Alt key while typing in the numeric pad, you get really cool characters. But I don't think Microsoft allows some of those really weird characters to be used as part of your password. And here's some character maps. So password managers are really important, specifically if you're a network administrator or enterprise administrator, or any type of administrator. Have a password vault. It helps one super long password to store all your other passwords that's encrypted. 3 basic types of password managers: password generator, online vaults, password management applications. Protecting password digest. One method is to use salts. So essentially what a salt is, after you created a hash, right? After you have a hash, you append an extra random string, whether it's a date or timestamp. And you guys will learn this in the next week's slide, but essentially it changes when you add even one bit, one letter within a file or a string or whatever. It changes the hash of that item. And so once you get the hash, to better protect your digest, is you add salt, a random string, timestamp, date, whatever it is, to that item, and it creates a completely new hash, which is a little more protected. Using the hash algorithms, passwords can be protected by adding random strong to the user and clear text password before it's hashed, make dictionary and brute force attacks much slower, and limit the impact of rainbow tables. Another method is to use key stretching, a specialized password hash algorithm that is intentionally designed to be slower. Two key stretching algorithms is BIRIPT and BPKDFD2. Recommendation for enterprises using salting and key stretching. Use a strong random number generator to create a salt of at least 128 bits. Input the salt and the user plain text password into PBKDF2 algorithm, and it's using HMAC SHA-256 as the core hash. Perform at least 30,000 iterations. Capture the first 256 bits of output, and then store the iteration count and salt in the password digest in a secure password database. All that aside, authentication, the most significant way, there's different types of authentication methods: multi-factor authentication, single-factor authentication. Multi-factor authentication is a buzzword, or it's not, but technically it's an important word. Multi-factor pretty much says that you have to have two different types of authentication methods to successfully authenticate to a system or a resource. For example, if you have a password and biometrics, that's two different types of credentials that you can use to authenticate. So multi-factor essentially is, there's three different aspects of multi-factor authentication. There's something you know, something you have, and something you are. So you need at least two of those three to ensure that you're using multi-factor authentication. So the most widely used is something you know and something you have. So when you're logging into your bank account or your medical, medical stuff online, usually you type in a password. That's something you know, and then once you try to log in, you'll receive a text or a phone call, or you have to verify via an app. And when you verify or receive that text, that's something you have. So that's your second factor authentication. That's your second credential, and that's how you log in. Using multi-factor authentication, it's really good against spoofing, people being fraudulent and trying to act, because passwords are so easily gathered and utilized for nefarious purposes. Single factor is just using one type of authentication method. Most common items used for authentication are tokens, cards, and cell phones. So tokens, it usually provides a one-time password, and then it rotates every 30 seconds or so. You can download tokens, we're talking about hardware tokens. Sorry, I'm going to make sure. Okay. Hardware security token is typically a small device. And then there's also a software security token, which you can install on your computer or smartphone. Usually these are, a couple known ones are Microsoft Authenticator. Oh gosh, I don't remember the other ones. I don't remember the other ones that are called. There's several different authenticator apps out there. I think Google has one. RSA has one, I think. but essentially it generates a 6-digit PIN every 30 seconds as your second factor of authentication usually. 2 types of OTPs, one-time passwords. Time-based one-time password synced with authentication server. Code is generated from an algorithm. Code changes every 30 to 60 seconds. And then the other one is a HMAC-based one-time password, event-driven. Any changes within when a specific event occurs, you're going to have to enter a new one, or it changes. So one change is based on time, one change is based on an event. Advantages over passwords: token code changes frequently. Attackers would have to crack the code within time limit, so they have 30 seconds to crack the code. Users, and they would probably have to have the device or the thing that's generating that one-time password. Users may not know if password has been stolen. If token is stolen, it became obvious, and steps could be taken to disable the account. So a smart card contains an integrated security chip that holds information and can either be either a contact card, a pad that allows electronic access to chip contents. Contactless cards, so proximity cards when you scan your badge in and out, require no physical access to the card. Common access card issued by the DoD, barcode, magnetic strip, and barrier picture. Usually people of military have these CAC cards. A smart card standard covering all U.S. government employees is personally identity verification standard. So smart card pad. So cell phones are increasingly replacing tokens and cards. A code can be sent to users' cell phone through an app or device. So when we talk about one-time passwords, up here we're talking about the software security token. But down here, when we're talking about cell phones, we're talking about people texting you or giving you a call. So we just talked about something you have. Now, something you are, biometrics, it's either standard or biometrics or cognitive biometrics. So standard biometrics is like a physical feature of yourself. Fingerprint scanner, retinal scanner, voice recognition is also used as a standard computer microphone to identify user based on the unique characteristics of voice. Iris scanner uses webcam to identify the unique characteristics of the iris. Facial recognition. I want a cool talk on facial recognition. Facial recognition actually looks at your, the physical aspects of your face, but it compares it to the lightness and darkness and the shadows of your face in order to verify that you are that same person. The only disadvantage of biometrics is the cost, and readers have some amount of error, and they can be tricked. So cognitive biometrics relates to the perception, thought process, and understanding of the user. Easier for users to remember because it's based on the user's life experience, difficult for attackers to imitate. So pretty much it's like a cognitive biometric is something that happened in the past, I guess. Picture password introduced by Windows. Users select a picture to use for which there should be at least 10 points of interest that could serve as landmarks or places to touch. So picture select a picture to use for which Other examples of cognitive biometrics require users to identify specific faces. User selects, another one is a user selects one of several memorable events. Something you know, right? So behavioral biometrics authenticates by normal actions of the user, keystrokes, attempts to recognize typing rhythm, and also provides up to 98% accuracy. Uses two unique typing variables: dwell time and flight time. Dwell time is the time it takes, like one oscillation, how long it takes you to press and lift up your finger from one key. The flight time is time between keystrokes. So going from P to A, right? Holds a great amount of potential and requires no specialized software. So this, for example, this it creates a baseline, right? It creates a baseline. This is the normal frequency of, dwell time and what's it called again? Flight time. And if anything goes over or under, then they're going to be unapproved. Geolocation. Let's see. I think there was something else I wanted to talk about. Also click rate and how fast you move the mouse. That's also something that is also behavioral biometrics. So geolocation, the identification of the location of a person or object using technology. So where's the person located when they log in? There's so many security tools, especially with Microsoft nowadays, they have geolocation blocking abilities. So if you get an email from Africa, most likely there's a conditional access policy which you can put in to block all emails outside of the United States. Usually it can indicate if an attacker is trying to perform a malicious action, and you can detect IP addresses. Some websites may require a second type of authentication code sent as text to cell phone number on file. We just talked about that. So identity management. Essentially using a single authentication credential shared across multiple networks, which is it is called federated identity management when networks are owned by different organizations. Single sign-on holds promise to reduce burden of usernames and passwords to just one. So essentially, use your one login, and you can access everything that you need to. And you don't have to keep on retyping your password and credentials every time you want to access an application. Examples of SSOs are OAuth, OpenID Connect, and Shibboleth. OAuth is the most prevalent and the one most oftenly used. So for example, if you're trying to get into a specific website and it's asking you to type in your Gmail account, it'll use OAuth to, or log in with your Facebook account. You're actually using OAuth, single sign-in. So you'll type in your Facebook account information, and then it'll verify you from that. It'll use single sign-on to get into whatever application that's federated with Facebook. So managing user accounts, passwords, it can be done by setting password rules. Too cumbersome to manage on a user by user basis. Security risk if one user setting is overlooked. Preferred methodology is to use group policy. Group policy, push down a policy where everyone has to, it's required to be set. It's like changing the settings for everyone. You change the password policy settings for everyone and the account lockout policy for everyone at the same time. So I highly recommend moving at least for the state of California. at least in the public sector, I think all admin credentials need to be over 16 characters. And then all user accounts need to be over 8 characters based on the SAM, based on NIST 853 framework. So other steps to take, a shared account, a generic account, and a guest account should be prohibited. Closely monitor and any privilege accounts, disable account passwords instead of deleting accounts no longer being used. Create strict policies regarding password recoveries for account management and ensuring security over accounts. So remove guest accounts, closely monitor privilege accounts, disable account passwords, and then create strict policies around those password recoveries. Transitive trust, a two-way trust between that is automatically created between parent and child domain in a Microsoft Active Directory forest. When a new domain is created, it shares resources with its parent domain. By default, it can enable an authenticated user to access resources in both the child and the parent. Authentication and can enable an authenticated user to access resources in both the child with its parent domain by default. Yep. Okay. So chapter summary, we talked about authentication. We talked about authentication and passwords. So authentication credentials can be classified into 5 categories: what you know, what you have, what you are, what you do, and where you are. Geolocation is where you are. Passwords provide a weak degree of protection and must rely on human memory. And most passwords today are attacked offline through dictionary attacks, brute force, rainbow tables. Attackers steal encrypted password files and then use that encrypted password files and try to use their attack methodology on those. A dictionary attack begins with the attacker creating a digest of common dictionary words, which are compared with those to the stolen password file. So remember, the password file has a bunch of digests for the computer that are passwords. Remember, each password has its own digest. So it goes through the pre-created list of digests of dictionary words, just compares them until it finds a match. Securing a password from attacks depends upon the user as well as the enterprise. Security experts recommend that technology be used to store and manage passwords called password managers. Another type of authentication credential is based on the approved user having a specific item in her possession. So that's something you have. Usually it's a token or a device or an application. Rotates a password every 30 to 60 seconds. Biometrics is using, some usually a human element. And there's 2 different types, standard and cognitive. Behavioral biometrics, it authenticates based on normal actions the user performs. Single sign-on allows a single username and password to gain access to all accounts. And then group policy, use group policy to push down password restrictions to the entire group at once. From an administrative standpoint, it's a lot easier to manage, increases IT hygiene, and it's the best way. And group policy should be used in your organization as a whole, for not just account management, but for some of the standardization settings for all your computers. With that, that's chapter 11. Thank you, everyone. Hope you have a wonderful day.